Hello and welcome. If this is your first time visiting, please be sure to check out my other repair videos. To support the channel for free, all you have to do is subscribe, comment, and like. Now let's get on to today's video. Hello and welcome back. If this is your first time visiting, I certainly appreciate you guys giving me a chance and checking me out. We're back today on the 2000 Honda Accord with its idle issues. I know this has been a kind of an ongoing saga with the channel here in the last couple of videos, but I finally figured out what's wrong with it. In the previous videos, I did some things that I wasn't too proud of. I kind of loaded up the parts can and went after something that I probably should have tested a little bit further. And what this video is going to be about is just like my last word in Honda idle and testing and figuring out what's wrong with it. Now, what this car is doing, it cranks and it runs just fine. There's no issue with it until it gets up to operating temperature. You'll see once it gets up to the full temperature, you see the idle start to creep up. It'll go over 1,000 RPMs. After you drive it a little bit, the idle will actually start to bounce and surge on this car. Now, what that is that's a fail-safe that Honda has programmed into the computer. That way, if the idle is getting away from it, it doesn't peg against the rail limiter. What it'll do is it'll just sit there and turn the fuel injectors off, and then the idle will just bounce. So that way it's impossible for it to actually peg itself out. Now, again, with mine, it does not do it at low temperature. It only does it at the higher operating temperatures where it's supposed to be. And so that's been an intermittent problem. It was one of the things that made it a little bit harder to figure out what was going on. So this is going to be my final word on Honda idle issues. I figured out what's wrong with this car, and I'm going to show you the proper way to test it and go about that. Here we go. All right, let's go over a couple of components that have to do with the idle that's on this car. Of course, you have your air coming through your box here, moves down and goes into your throttle body. After the air enters the throttle body, this car is equipped with what's called a MAP, or a manifold absolute pressure sensor. And everything that this car does to regulate the fuel delivery is based off how much air that this thing says is in the manifold of the car. Some cars have a mass airflow sensor, which is usually somewhere along this tube here, or it could have a combination of the two. This car is just a MAP, or manifold absolute pressure system. What happens is if you have air that enters the system after the MAP sensor, then you have unmetered air, and the computer is not aware that it has that much air in the system, and that is going to cause you a problem. So that would probably take the form of a vacuum leak. Any air that's coming in any of these hoses that is not metered is going to throw off your air fuel mixture, and it's going to cause you to have problems at any speed. So what I would tell you, the very first thing that you should go after for an idle problem on this type of car is a vacuum leak somewhere after the throttle body. You have unmetered air entering the system. It's throwing your fuel air mixture off. The computer doesn't have the right numbers to work with. All right, and to test for a vacuum leak on a car, if you take it to a shop, they probably have a smoke machine where basically they just forced air with vapor into the throttle body and into the manifold system and all the vacuum lines, and it'll start to smoke. You'll see where it's coming out of the engine. Those machines are expensive. You probably don't have access to one in your garage, so I'll tell you the other things that you could do to look for a vacuum leak is either spray, get your bottle of water with a little bit of soap in it, and you want to spray all of the areas where you have vacuum lines. Like here would be a connection here, all along here up to the top, and you can see where you have these two hoses come in here. This is a two-piece manifold. We have a top and a bottom. There is a gasket in between, so you probably want to check in between that. Anywhere that you can see where you have a vacuum line run to the intake manifold on this car. Your leak could also be coming from the actual seal of the intake manifold against the back of the head. That would be very hard to find. You'd have to be crawling around up underneath the engine with it running, and I don't suggest you do that. If you can't find the vacuum leak yourself, take it to a shop and get it smoked. The other thing that you could do, which is what I do, and it's probably not as safe, as I actually use carb cleaner. So I'll spray the carb cleaner in different areas where I suspect a possible vacuum leak, and what you're waiting for while the engine is running, you're waiting for it to stumble. And once you find that leak, you need to get it plugged up, reset everything, see if that took care of your problem. It may take care of it, it may not. You may have to keep hunting like I've done for the last couple weeks with this car. Another method that you could try like let's take the brake booster, which is this vacuum line here. It runs to your brake booster back here. The leak could actually be in the brake booster and you could not find it with a water or a carb cleaner. So what you can do also is you can come in with the engine running with like a pair of needle nose pliers, and you can squeeze off, don't cut it, don't break it, just give it a good squeeze, and you can seal off that vacuum inlet to the engine. And if the idle changes, then you know that you may have a problem there. That same method would work for any of these hoses like this. You would just need to be careful and make sure that you're not damaging the hose when you do that. The other number one, what I would say cause for a bad idle on this type of this vintage of Honda is going to be a coolant, air in the coolant system. This would be the very first thing I suspected if I had done something like drain some coolant out and had to do a repair and then put the coolant back in and I didn't get it all bled out, then you're liable to see that bouncing. And what causes that on this particular engine, this is where my finger is pointing, that is where your temperature gauge or sensor is at in the car. Those things need to be completely submerged underwater. If you have water splashing on it, the computer doesn't read the temperatures right, and it starts to think that the engine has not warmed up yet. It raises the idle, and then it gets out of control, starts to bounce, and there you go. So that would be probably alongside the vacuum leak the most likely cause for a problem. Now we'll talk about a couple other things that are probably not the cause, but you should probably still know about them anyway. Okay, another thing that could be causing idle issues with your car is your PCV system. PCV is positive crankcase ventilation. The PCV system basically removes harmful vapor and gases out of your crankcase that are developed during engine combustion as the engine runs. I won't go into it any deeper than that. That's just the main thing you need to know. So what Honda does is this pipe here that goes into your air supply from your filter box pulls air into your intake, your valve cover here. This is the actual PCV valve, and what that does is pulls air out. So it's just moving air through the system to vent that gas out, and then it goes back into your intake manifold here. Now the PCV valve has a spring in it. Honda knows exactly how tough that spring is. Once a vacuum is applied to the back of it, it'll actually open this up and it starts to pull air into your intake manifold. Again, the way this is designed, it's basically a controlled vacuum leak that the car knows about. So a fault in this part of the system could be causing you to have an idle problem. I'm going to go over here on the bench and I'm going to show you a PCV valve that does not work and compare it to one that does work properly, so you'll get a better idea what I'm talking about. All right, here is the PCV valve for that car. This is a grommet that came with my kit. That just goes down into your valve cover to for where this plugs into it. This is the PCV valve that came off of my car. And just looking at it like this, let's just go over it. You have what's called a pintle, or a piece in here that's attached to a spring, and that keeps that sealed off when there's no vacuum present here. Once you put vacuum pressure on this opens up and it starts to vent the crankcase vapors out and back into your intake system. This one is actually hung open. It will move air through it whether there's vacuum present here or not, which is not good. You can shake these things if they're bad. If you don't hear anything rattling in there, that's a sign that it's bad. It doesn't mean that it's bad. And if you hear one that does rattle, that does not necessarily mean that it's good. How you can test this is that you can actually try to blow air through this side. You should not be able to blow air through this side, but you should be able to suck air through that side. That's basically how your PCV valve works. If you have one that's hung open like this is, then when the car's sitting at idle or low RPMs where there's not very much vacuum here, it's still just sucking air straight through this, and it's something that the computer is not expecting, and that could be causing your problem. All right, let's move on to the next one, the idle air control valve. Okay, so here we have the idle air control valve that came off of that car. It has places here to run coolant through. It's just to warm it, and then this is a vacuum line that's hooked to your manifold also. And this is attached to the back of the throttle body. It has opening here. Don't worry about this. That's just for the coolant to move through it to keep it warm. And then you have two chambers here. One of the chambers is attached before the throttle body to the air system, and one of the chambers is attached after the throttle body. And what happens is when the engine is idling, and say you sing at a stoplight, you've seen this before, your cooling fan kicks on, you can see the RPMs drop and then they'll slowly come back up. That's your idle air control valve working. When it sees the drop in the RPMs, it opens up and allows a little bit more air to get past the blade on the throttle body, and it raises your RPMs back up, and it will sit there and meter itself, you know, kind of back and forth, and just so your idle stays at that desired where the computer is set for it to be at. Now, when one of these goes bad, the best way I can tell you to test it is with the car's acting up and you see the idle's misbehaving. If you come back here with a screwdriver and you give it some taps while the engine's running, and that actually changes the idle, then you may begin to suspect that this could be your problem. Or you could also just reach back and unplug it, and if the problems go away, if the car starts to idle normally with no load on it, in other words, you don't have the AC cranked up and all your coolant fans are running, then the car should sit there and idle fine with this unplugged. If this is plugged in and it's misbehaving, then this is a good chance this is your problem right here. All right, with those things all covered, what I'm going to do now is I'm going to get this car up to operating temperature, and I'm going to make it misbehave, and we're going to do some of the tests I just showed you, and we're going to see if we can't figure out once and for all exactly what's wrong with this car. All right, guys, I've got the car up to operating temperature now, and the first thing that you should notice, I have the engine speed and short and long-term fuel trims pulled up here. The RPM is staying above 1,000. This car should idle between 750 and 800. So you know already that you have the car is idling higher than it should be. It's not misbehaving yet, but I can make it misbehave. I've also pulled up the short and long-term fuel trims because I was expecting a vacuum leak. And what you would generally see with your fuel trims if you have a vacuum leak is that the engine leans out and that it adds more gas to it. My numbers are just barely positive right now. My fuel trims generally on this car, before it started having this problem, they run around the -6, -5 in that neighborhood. When the problem starts, they go positive. This is probably not enough to really make you suspect a lean condition in the engine, but that RPM level is not right. That should be 750 to 800 range. All right, let's see if I can get the car to act up now. All I had to do was blip the gas because I knew it was going to happen, and you see my RPMs right there, and you can see on the tach as well that little subtle bounce. All right, so here you can see the actual Honda programming coming into effect here. This is my fuel injectors. You see they cycle up to 3 and then they turn themselves off. Cycle up to 3, turn themselves off. So this is the fail-safe in operation on this car. All right, with the car misbehaving, I'm going to go back here and tap on the idle air control valve. It's not affecting the RPM on the engine. So the next thing I'm going to do is very carefully reach back, and I'm going to unplug it. So with the idle air control unplugged, you see it even got worse. Plug it back in, it just starts to slow down. So it doesn't really, the problem doesn't go away, so I'm not going to suspect the idle air control valve. So at this point is when you would start testing for vacuum leaks on the system. And again, I showed you before, you can come in here with a pair of pliers and clamp off. Just don't tear anything up when you do that. If you don't notice a change in the engine RPM as you're testing these different places, there's probably not going to be a problem. All right, the PCV valve testing, again, you can just pinch this off, and you notice my engine starts to behave when I pinch mine off. But there is nothing wrong with my PCV valve. Okay, now I'm going to come in with carb cleaner. This is dangerous. You could actually start a fire like this, so you should probably have a fire extinguisher close by when you do these types of tests with this. I'm going to come in here and I'm going to spray different parts of my vacuum system, and I'm waiting for the engine to stumble. Go around the throttle body, see if anything changes. One last thing that you do want to check on your engine is where your fuel injectors go into the intake manifold. There are rubber grommets on that, and I'm going to go ahead and spray my number 4 fuel injector right now. We're going to listen to the engine change. All right, I know that was a little bit loud with the engine running if you didn't hear everything that I was saying exactly, but what turned out to be the problem was one of the grommets that goes around the fuel injector where it plugs into the intake manifold. That is a source for a vacuum leak, and it took me a while to find it, but I finally found the thing. What I suspect happened is when I rebuilt this engine, and I had an aftermarket kit that had all the grommets and washers and O-rings and all that, and I used that to put the fuel injectors back into it. These are not Honda original, so you're going to run into problems when you don't use OEM, and that could be part of it. It could be that I did not install it right. I'm not going to discount that either. So what I'm going to do is take that one out. I'm going to grease up all of the grommets and O-rings and get that put back in. I may have a video out next week showing how to do that. No big deal. But that was the idle issue all along. At least I hope it was. I'm going to get this thing back together, and I'll try to be honest. I'll come back and tell you, nope, that didn't fix it. Sometimes these idle issues are just something that you just have to keep chasing. As you've seen before in my previous videos, looking for what may be causing that. I found other things wrong with the car. I found a broken radiator. I found a TPS sensor that was sticking. And so I kind of eased up to it, but I think I'm finally to the point you saw where the engine stumbled and changed its RPMs when I sprayed that grommet around that fuel injector. So hopefully that's going to be the end of this. At any rate, I appreciate you guys watching today. I will check you out on the next video.